Let's have some recapitulation of these three parameters of a magnetic material. Permeability indicates how easy the material to establish a magnetic field. Retentivity indicates how well the material remains magnetized when external field or magnetizing force is removed. Coercivity indicates how difficult the material to be demagnetized. Materials with high retentivity and high coercivity are used for making permanent magnets, such as neodymium and L-nickel magnets. They are strong magnets. We discussed about them in Part A. Materials with high permeability and low coercivity are used for making radio antennas and ferrite bits of computer cables. These two applications has been discussed in Part A. This type of material with high permeability and low coercivity is also used for making solenoids, electromechanical relays, doorbells, circuit breakers, and etc. This is an electromechanical relay. This is a structure showing how it works. Inside has a solenoid. The electromagnetism of the solenoid must respond fast to the on and off state of the switch. This doorbell has two solenoids in it. The electromagnetism produced from the solenoids attracts this metal bar and let it hit on the doorbell. In order to hit the doorbell fast, the solenoid must be able to respond quickly to the on-off states of the current flowing through the solenoids. Materials with tall and narrow hysteresis loops have high permeabilities and low coercivities. They are needed in many applications as just mentioned. In the next slide, you will know the detailed reasons behind. An electromagnet can be made by wounding conducting wire on a magnetic core. In many applications of electromagnets, the core is required to have high permeability and low coercivity. High permeability means that if a current flows in the coil, a strong magnetic field can be produced around it. Low coercivity means that the core can be easily demagnetized. The magnetic field disappears as soon as the current is turned off. Low coercivity also implies that the magnetic field strength can be varied easily with the amount of current, and the magnetic poles can be reversed easily by changing the current direction. Electromechanical fire alarms, doorbells, relays, and circuit breakers require the magnetization to follow the current quickly and sensitively. Therefore, their magnetic core materials should have low coercivities and high permeabilities. There are two types of magnetic strip cuts. High coercivity magnetic strip cuts are more difficult to encode but less likely to be erased unintentionally. They may find applications in cuts that need to be used frequently for long term, such as credit cards and employee ID cards. Low coercivity magnetic strip cuts are good for short-term applications such as single-chip magnetic train tickets. In this video, you have learned that solving a magnetic circuit can be made simple by taking analogy to an electric circuit. pH characteristics of magnetic materials vary from one to another, and you have learned different pH curves offer their advantages over the others in certain applications. You will learn about electromagnetic induction in Part D.